Hello, welcome back. This is Arduino Programming Fundamentals Tutorial 2, Input and Output. So in this lesson we are going to be making some inputs and outputs. Obviously we're going to add some components to our Arduino, we're going to flash a lot of LEDs, we're going to want to make some little sound effects, and then we're going to use the switches to make some sounds. The switches will become our input, whereas our LEDs and speakers are our output to the system. The sort of thing we're going to be aiming to make will be something a little bit like this. We can go straight to breadboard. We could, use a big Arduino, proper breadboard, LEDs and wires, but it can become a little bit fiddly. Again, it's really nice to start in Tinkercad and try and get things working before we worry about the actual kind of wiring. Okay, so let's jump over into Tinkercad. So from last session we've already got the Arduino, we've got a little code for making the one LED flash. So I'm going to drag some breadboard on. So I'm just going to close the window down. I'm going to click on here and look for some breadboard. So click on breadboard. I'm just going to drag the small one across. If you've not used breadboard before, this entire wire is connected, so anything we plug to this will link itself together. Same for the positive rail. Every single pin is connected. On these rails, it's everything up and down is connected. It just makes forming connections much easier than trying to solder things together, again, especially for prototyping. So I'm going to grab some LEDs. Okay, so there we go, there's a simple LED. I'm just going to put it where I can see each one. I'm going to have a red LED so you can change the colour of it. We can also rename it if you would like. I'm going to drag another LED on. I'm going to make this one green. I'm going to move that over. I'm going to drag another one in the middle of them. And that one's going to be orange. So basically I've got some traffic lights going off. So each one of these pins is the ground. But before I go put the circuit back to each other, I need some resistors. So if I just grab, oops, didn't mean to rotate that. Okay, so there's a resistor. I'm going to drag a resistor on. I'm going to drag, I want this to be 220 ohms. I'm going to drag another one on. Again, 220 ohms. Oops. And then the third final one. 220 ohms. Okay, so now we've got the pins, the main components on the board. I'm going to now connect it up. So I'm going to go from pin 2. We don't use 0 and 1 at this point because 0 and 1 are where the USB information comes in, or other serial communication, i.e. if you want to hook up to Bluetooth. So if I hook up pin 2, I'm going to drag that to pin 3 because that's what's connecting this to our anode of the LED, the positive part of the LED. If I just double click the wire, I can put little curves into it, so it just makes it look a little bit neater, so we're not blocking the other components. So again, pin 3 is going to go to our LED over there. It doesn't matter if it's crossing over, it just makes it a bit easier to see what we're doing. Then finally pin 4. So if I just click that a little bit. Okay, so I've now got the pin outs connecting up to our LEDs, then finally to bring these back to the ground. So like I said earlier, it's fully connected, so if I just drag the ground to that ground connector, all of these negative parts are going to come straight back to the ground of the Arduino. Again, I'm just going to make that look a little bit neater so it's not blocking the other pins. Not that it makes a difference at this point. And now I can finally just connect that to there, that to there, and that one to there. Now if you like, you can change the colour of these wires if it makes it easy for you to follow. But now I've got my little circuit made up. The next bit is to program it. So if I bring back code, I need to change, like I said earlier, I need the pin mode. I need to make sure pins 2, 3 and 4 are set to outputs. So I'm a bit lazy, I'm a big fan of copy and paste. So if I just copy that, so it's pin 2. And like I said in the previous session, if you forget to do this, it might work sometimes, and other times it may not work. There's no guarantee either way, so try and get into the practice of making sure you do set the inputs and outputs properly. Okay, so I've now initialised these pins to be outputs. I'm going to leave that bit of a loop in there, but again, I'm lazy, I'm going to copy and paste it. So if I just copy and paste this to pin 2, and again, copy and paste, now it's pin 3. Oops. Pin 3, and finally pin 4. and hopefully if I've not made any silly mistakes, when I run this we should see a little sequence of lights flash on and off. It should be fairly quick. Okay, there's a bit of a sequence going. It's a bit too fast, but you kind of get the point. We've got a nice little sequence of LEDs flashing on and off, so you could now go make some Christmas decorations. Okay, stop that for the moment. So your challenge now would be to go and add some extra LEDs, as many as you like. Obviously we've got up to pin 13, so you could easily have another, what, 11 LEDs sort of running along there. Is it 12 LEDs? I'm not going to go any further because it's boring to watch me just drag and drop wires. But I'm going to come back and I'm going to add a little speaker. So I'm going to look for a speaker. Doesn't seem to like these keyboard shortcuts while I'm recording. So if I just come back and add a speaker, it's just a little piezo buzzer right now. I'm just going to dump that up here. I'm going to connect pin 12. I was about to do pin 13 then, but remembered we're connected to that LED. So I'm just going to do pin 12, just to allow myself some LED space. That's just going to go on one side. The piezo doesn't really matter which way you connect it up. I think some people would like to do resistors on this, but I'm just going to drag it straight to my negative rail. Okay, so that's our little speaker connected up. I'm just going to move that over there again to try and keep it look a bit more orderly. The speaker's really easy to work with. If I just go into code. Now, in case you do move things around, I'm not going to just keep with the pin numbers. I'm going to create a global variable. So this is going to keep track of things. And if I say int speaker 1, because you might want to add two speakers at some point, equals 12. So that is going to pin 12. In our pin mode, it's the same as it would be before. I'm just going to set pin mode to be an output. So instead of saying pin mode 12, I say pin mode open bracket, and now I can say speaker 1. This is again a really good idea, because what if you start moving things around on your prototype board, you need to move wires around, it's much easier to just come and change this pin number up here, let the rest of the code update itself, rather than you going through all the code changing it a little bit. So if I just say output, okay, so I've got speaker 1 as an output. Now I can come down here. I'm just going to do this at the very first bit to do. If I say the command tone, so tone is going to put obviously a tone to the speaker. Open bracket, which speaker I want it to go to? Well, speaker 1, comma, and now I need to tell it what frequency do I want. I'm just going to go straight in at 1000, just 1000 hertz, and I'm then just going to say delay. So how long do I want this note to go on for? So let's just say I want it to go for 1/4 of a second. What I also need to do is make sure I turn it off, because even with the delay, if I don't turn it off, it'll just keep making a high-pitched squeak throughout the rest of the program. It's really irritating. So if I just say no tone, this will then turn it off. So if I just say speaker 1, and I now play this, you might not be able to hear it, but I'll give it a whirl. So it's flashing LEDs and then making the speaker sound. Okay. And again, if you want to make it a little bit of a higher pitch, again, I'm just going to copy and paste this. So if I now say speaker per tone 200, but I'm going to make it a little bit of a shorter noise, and start that simulation. It's starting to sound a bit like a modem or like an old Spectrum. Okay. So I did mention about doing for loops, doing loops, repeating instructions. I'm going to, I'll keep the lights flashing for the moment, but I'm going to delete this little bit of code. So a command we can do is called a for loop, and a for loop lets us repeat through some instructions for a set amount of time. So if I say for, I've got little brackets again, so I need an integer that's going to keep track of our little counter, and the standard letter for this is I. So if I say for int I equals 1000, so the first note we're going to make will start at 1000 hertz. I want to say, I don't know, let's go up to 2500. So whenever the counter is less than 2500, it's going to keep on looping. And then we're going to add 1 to it. So if I just say I++, so each time this little loop runs, it will go up in increments of 1. So I'm just going to put a little brace around there, brace around that. That looks ugly, so I'm going to just tab this bit of code in, bring that back a little bit because I can't cope with it looking too messy. So this is now basically going to go 1000, 1001, 1002 until it gets to 2005. To speed this up a little bit, sorry, 2500. To speed it up a little bit, I'm just going to say we're going to stop for just 1 millisecond. I'll take out the no tone and I'll put that outside of the loop. Okay, so when I play this, we should get kind of a noise that's sort of spiralling up. Unless, of course, I've made a silly mistake because I forgot to change that. If I just put the letter I, whatever the counter represents is what it will loop for. So if I just press start now, I'm going to stop it there because it gets a little bit high-pitched. I think it can go from about 0 to about 5,000. That's something for you to experiment with because I don't want to upset any sort of resident dogs. The other thing I can now do is if I just copy and paste that, I can count backwards. So if I say for int I equals, we'll go to 2,500, and while I is greater than 1,000, I can say I minus minus. So we're going to come back down. Oops, clumsy typing. So we're going to come back down. Now, this gets a little bit slow. Well, let's see how far it goes. Now it does sound much better. It does sound much better if you're actually coming through a real piezo. This is still just a web-based little speaker. The real things, they still sound awful, but they sound a bit neater, a bit cleaner. It's basically the way the little sort of squeezy toys work with a little bit built-in tune, like the Build-A-Bear things. So the next bit, what I can do is if I come back to this I++, we don't have to go up in ones. We can say I plus equals 5, and it'll go up in steps of 5, so 1,000, 1,005, 1,010, etc. Oops, I think I pressed my insert key. And again, same, if I say I minus equals 5, it'll come back down. Or I could come down even faster by saying I minus equals 10. So it'll count up in 5s, but count back in 10s. So again, if I just try that. But it's just a really good way of making these little silly sound effects. You might be more familiar with the sort of old arcade machines and the grabber machines. Okay, so what's next? The next bit is to add a switch. Now again, I'm a little bit lazy, so what I tend to do is look for easy ways of dealing with things, particularly with the circuits. So I'm going to grab a switch. Oops. Grab a switch. I'm going to grab a push button switch. Now, what always I struggle with is which way connects to which. You know, which terminal is actually forming switch. So it might take me a couple of goes to get this right, because 2 of the pins are already soldered together on the inside of the switch. And it's not going to give me a clue. Right, so the reason I'm saying I'm lazy is I like to keep my circuits as simple as possible. So a lot of people will use resistors, but the Arduino's got a built-in something called a pull-up resistor. So if I just drag another wire, come down to that pin, I'm hoping I've got this the right way around. If not, I'll just have to rotate the switch, and I'm going to come straight to ground. What's really important with this is if you're going to connect the switch, you are basically creating a short circuit. But I said the Arduino's got a built-in resistor. So I'm going to go into the code, and if you get this code wrong, this is where you can start damaging things. I'm going to say pin mode, and it's called a pull-up resistor. So I've just hooked that up to pin 5. I think to make things a bit easier, I'm going to change the colour of that. So it's gone to pin mode 5. So pin mode 5, comma, and we want input pull up. So this has now got a built-in resistor, so we can just connect this circuit. But what it's also going to do is, it's always going to be on. When we press the switch, it'll break the circuit. That'll then will act on it. Because of code, it makes no difference whatsoever. We can just come down and say if digital read, so we're reading what the state of the pin is. Gigical, yeah, good spelling. Digital read pin 8. Is it pin 8? No, it's not pin 8, it's pin 5. Digital read pin 5 equals low. Now notice I've put 2 equal signs in. 2 equal signs means are these the same? Is pin 5 low? It's checking for equality. A single equal sign like this means we are assigning. We are saying speaker 1 is 12, whereas this we're saying is this low. So one, like I say, one is a assignment, one is equality. So if digital read 5 equals low, so we've broken the circuit, that's where I'm going to make this little sound play. So if I just open bracket, well sorry, a brace, come down here, close that brace, I'm just going to tab all these in so you can see where it starts and stops. It doesn't really matter, it's just for visuals. Hopefully if I've done this correctly when I run it, now I have forgotten, no I've not forgotten, it's alright, I thought I'd forgotten to assign it but I've not done it just there. If I now run this program, we should just see the LEDs flashing, or not. Okay, I've definitely made a little mistake. I'm just going to rotate this switch around. Oh, that's definitely not right. Okay, I'm just going to pause the video a moment. Okay, the simple mistake I've made is these two wires are already connected. All I've got to do is delete this little connector just here and connect these instead. That's why I'm saying again, it's so much better to do things in Tinkercad first and make sure it's working before you start soldering things up and then risk damaging stuff. So if I now press start simulation, the circuit's no longer connected. As soon as I press the little switch, there we go, it goes back to flashing, plays the horrible little sound. So this is really where it's over to you now. You know, we know how to do some little inputs, we know how to do some outputs, we know how to make some sounds. Have a go at actually using for loops to turn LEDs on and off. I mean, okay, I'll give you one more little clue with this. Rather than just turning them off and off like this, I can say for int, again int for integer, this is 2, 3 and 4. So if I say for int 2, for int I equals 2, so the LED 2, I less than, well it's pin 5, so I less than pin 5, I plus plus, I could now just drag this, and again to show how we can make code look a little bit neater, I'm going to get rid of all that. I'm going to bring this inside the for loop. I'm just going to say pin I, pin I. So this is going to go 2, 3, 4, 2, 3, 4. So I'm going to just tab that in again so it looks a bit neater. So now when I run it, it'll still look the same, other than I've skipped out pin 13. But it'll keep in sequence. It's so much quicker as well. If I want to now slow the LED down, oops, I can't make a change. If I want to slow the LED down, I can just change one little bit. There we go, a little bit slower. So again, what I'd encourage you to now do is make it flash back into the sequence. Add some more LEDs. Make it play a different note depending on what LED is playing. Add some more switches. You know, it's important to experiment and expand. Okay, so that's it for this tutorial. In our next tutorial, we're going to be looking at how we can control motors. Okay, so I'll see you then.